Welcome back. Today we'll start with lever. The second part of machine. Just joking, that's not lever. Lever, it's lever. Today we'll do lever. So first let me tell you what it is. Meaning the definition. Okay. So what lever is? It is any straight bar, a rigid bar obviously. It can be a little bit bent also. Like lever can be like this also. Okay. So if you take any straight bar and you fix any point on it like this, let's say this is the fixed point, fix any point on it about which this rod can be, rest of the rod can be rotated like this, it can be rotated like this, it can be rotated like this, then such a system is nothing but a lever. Okay, now I'm just drawing this typical diagram of a lever. Let's say this is the point about which the rod is balanced. Okay, now the force that you exert on the thing, obviously I have told you in the earlier parts only. Let me do it in a different color, it would be better, no? Yes, 1 second, like this. Yes, I'll do it in a different color. Yes, so whenever the force we are applying, that force is nothing but the effort. This I have told you in machines, I'm not going to repeat it. And the force that the weight is applying, that is the thing but the, what do we call it, remember, load. And in the case of this lever, this thing, this point is nothing but called the fulcrum. It is nothing but the fulcrum, and this coloring this, okay, this is nothing but the fulcrum. Now if you see the perpendicular, let me change the color here to blue, the perpendicular distance between the effort and the fulcrum is called the effort arm. So perpendicular distance between the effort and the fulcrum is nothing but the effort, I'm writing E arm. Okay, and then same way the perpendicular distance between the load and the fulcrum is nothing but the load arm. This is like if people ask you ever what are the components of a lever, this is what you should draw and explain in the exam. Okay, these are the components of the lever. Okay, now we'll talk about a very important part, that is called the law of levers. It's very easy, it's an actual application of the first chapter we learned, force. Okay, now if you can see a lever, let's say this is my lever, this is my L, this is my E. Okay, this is my L, sorry, this is E A, effort arm, this is my load arm, this is my effort arm, this is my load arm. Now okay, I'm just drawing this here. If you see, what do we know, that if this is the lever and if there is a force here F1, here F2, this is D2 D1, remember the principle of moments, this is the anti-clockwise moment and this is the clockwise moment. So by that formula we can say F1 D1 is equal to F2 D2. Remember, net anti-clockwise moment is nothing but net clockwise moment. Same way F1 D1 equal to F2 D2. If we write it better, we can write L into LA equal to, if you see, L into LA is equal to E into EA in that manner. E into EA. So I can write load into effort is nothing but effort arm by load arm. Do you remember what load by effort was? Load by effort was nothing but mechanical advantage. mechanical advantage. So if this law, a mechanical advantage is equal to the effort arm by load arm, this is the law of levers. Adding law of levers. Law of levers. Its statement is that the mechanical advantage of a lever is equal to the ratio of the length of its effort arm to the length of the load arm. Okay. Now we will do kinds of lever. Kinds of lever. Actually, there are 3 kinds of lever and very easy to remember the name. The first kind is known as the lever of the first kind. Second kind is known as second kind lever. Then third is known as third kind lever. Such easy names to remember. Okay. So as I was saying, in the first or the second or the third kind of lever we'll study. So in this, in many books, mostly Selena, only facts are given, reasons are not given, but I'm going to give you the reasons. Okay, about the facts. Okay, obviously about the facts. Reasons exams it will not come, but physics is such a subject. If you don't know the reason, how can I tell you? Like if I tell you the second lever, second kind of lever, ma is greater than 1, you believe me if I say okay, that's fine, for example purposes, okay. But if you don't know why it is greater than 1, why would you learn? It's not learning physics. So we'll start with the first kind of lever. Okay, first kind of lever. In a lever, this is the first kind. Okay, this lever I can also write it as low LFE. That means what? If there is a lever, the fulcrum is in between of the load and the effort. Okay, the fulcrum is between the load and the effort. Understand? For example, if you sit on a seesaw, that is a lever. Okay, now for example, if there's like this big rock, you what you can do, you can place a small rock over here, put one second, let me redraw this. Let's say this is the ground. Okay, so you put the stick here, you put a pressure here. Okay, so what happens is that a force applied is here. So what happens, see, you can see this is the point, so this becomes the fulcrum, this is my effort, this is my load, as you can see. So LFE. Understand? This is the first some example. A very important example is that of the steel yard. I'll give you the steel yard because it's mentioned in great details in the book. It's actually what, there's a ruler like this, there's attachment this side, there's a hook here, there is a hook here, and here there is one weight which is attached like this. Now what happens, if you want to find the weight of anything, you hang it from a support, you hang the weight here. Now this weight can move both sides. Okay, so when it moves, let's say at this point, let's say this becomes 8 centimeters. Okay, so by some calculation, I'm not going to going into detail, you can actually tell the standard weight. This setup is called a steel yard. So this steel yard is nothing but it is used for actually in the grocery shops, or like in the goods or trading market. What they do, they used to use this to measure all the, what do you call it, any goods they receive. Okay, so this is one great example you need to know. Okay, now we have to talk about the mechanical advantage of levers of first kind. Can you see this? Now let's say when the effort arm is greater than the load arm, meaning what is this case? Like this, put the effort here, the load is here. Understand? So you can see the load arm is less than the effort arm. So you know MA is nothing but EA by LA. So my mechanical advantage is greater than 1. Same way, now if the EA is equal to LA, meaning the effort arm is equal to the load arm, that means that, let's say this is equal X, this is effort, this is load. You can see both are equal, so I can say MA is equal to 1. Why? It will be x by x, x gets cut, equal to 1. So MA here becomes 1. Now let's say if the load arm is greater than the effort arm. Can be like this. If it is this, now the load is here, the effort is here. So this will be, let's say, y and x. So MA will be nothing but x by y, that is obviously less than 1 here. But obviously it's greater than 1. Like greater than 0, obviously. Okay. They can't be negative, okay? Their lengths obviously positive. They don't have, like, say, you don't say like that string is minus 5 meters. The string is always 5 meters long. Okay. So we understand one thing. So here you can say that in the first kind, okay, this is the first kind, MA can all be greater than 1, can be equal to 1, and it can also be less than 1. All three possibilities are possible here. What is the velocity ratio here? Can you do this? Velocity ratio here is nothing but the effort arm by the load arm. Okay. Now in this also, that can be greater than, VR can be greater than 1, because same reason I'm not going to tell you. You try to guess it. It is the same reason why VR can be greater than 1, equal to 1, less than 1. Okay, let me try to show you why. See, like if this is the thing, now after some time it has moved, let's say this much. Okay, after some time, so obviously it has traveled this distance. Let's say this is the effort is on this side, load is on this side. Okay, now if you see, this is theta, so this also has to be theta. Now let's say this is x, not x. Let's, you all know this, know that this length by the hypotenuse is nothing but cos theta, sorry, sin theta. So I can write what, this length to be what, can you tell me? Load arm cos theta. Because, am I doing the right thing? Yes, because this is the load arm. No, this part is still the load arm, and this thing is also the thing. Okay, so no, I'm doing it wrong. This is load arm tan theta. What am I doing? Load arm tan theta, and this will be effort arm tan theta. You know, because tan theta is nothing but perpendicular by height, sorry, perpendicular by base. So base is this here, this is the effort arm, this is the load arm. Understand? So let's try to prove it. Okay, so the distance it has moved, so VR is nothing but the, I told you how much the effort moves, and by the how much the load moves. So it will be nothing but EA tan theta by LA tan theta. So this gets cut, so this is EA by LA. Understand why this is theta theta? Like if there are two intersecting lines, vertically opposite angles are equal. Okay, this proof will never come, I'm just telling you how it is come. Okay, now let's talk about the levers of second gear. These things will not go so much, okay, in details. Second kind levers is what kind of lever we call them? That is we call E L F, elf, like in the Harry Potter kinds, elves. So what happens here is the fulcrum is on one side, the effort is on one side, and the load is in the middle. For example, the screw, whatever, whenever you bottle cap opener, okay, let's say here is the bottle. I can't draw so much well. Here is the cap. Okay, here is the thing. Okay, you apply a effort here, the load is in the middle, and here this is the fulcrum. This is the fulcrum. You can see. Now if you draw this load effort, if you can see this clearly, this is the effort arm. So this is the effort arm and this will be the load arm. You can always see that the load arm is obviously less than the effort arm. In this case we know what MA is always greater than 1. So in the second kind of lever the MA is always greater than 1. Now velocity ratio also in the same case it's greater than 1, because why? Because effort arm is greater than load arm in all cases. So these kind of lever are called as force multipliers because they multiply force. Oh, let me tell you one thing. Okay, remember this. Let's say this is MA. Make this chart MA and use. Okay, if MA is greater than 1, if MA is greater than 1, it is called a force multiplier. It multiplies force. It multiplies force. If it is equal to 1, it is a speed multiplier. It multiplies speed. Now if it is a what do you call it? No, not equal to, sorry, not equal to. If it is less than 1, then it is called speed multiplier. If equal to 1, not required for now. Okay, so levers of the second kind I told you, no, the velocity radius is also greater than 1, both are greater than 1, so they are obviously force multipliers. So first kind levers can also are all force multipliers, can also be speed multipliers, depends on you. Now let's go to the third kind. Third kind is known as the LEF, left, like left without a T, left. So you can always say how this will look. The effort will be, once again, the effort will be in the middle, the load will be in here, and fulcrum on one side. Okay, for example, how to show you, let's say when you're lifting something. Okay, let's say this is your arm. One second, trying to draw. Okay, this is your arm. Let's say, one second, trying to draw. Let's say, give me a second. Let's say there is this long stick you're trying to hold up. Okay, here you a little bit of biology. This is the humerus, and this is the biceps, and this is the triceps. So this part is nothing but my fulcrum. This part is nothing but no, what am I saying? This, not that part. This part is the load. This part is the load, and the effort is applied mostly by this type of muscles. Okay, now let's say if you are using a fishing rod. Okay, you're like this person using a fishing rod. Let's say this is a pond, you fish here and you want to pick up a fish. Then the load is here, the effort you're applying here, and you always push with your feet. So the fulcrum is nothing but, once an effort here, and fulcrum is nothing but the what do you call it, your legs that are supported by the ground. Okay, now let's talk about the mechanical advantage. Now if you see, this is E, sorry, this is E, this is L. Okay, so load arm, this is load arm, this is effort arm. So load arm is greater than effort arm. That means what? MA is less than 1. That means what? VR is less than 1. Wow. So what can we say? They are speed multipliers. Speed multipliers, ma less than 1, vr less than 1, and we have done. Nothing else is there. Nothing else is there. Levers are done. I think we'll finish it with one problem. One problem. So we'll do now one question to sum it up, because if you don't do a question, how will you know how to solve question? So this is the question. You can see this is a board question, ICSE 2011. So if you can do this, you know, this is the actually the hardest problem I could find, means in numerical for boards. Now see the diagram. Let me just tell you one thing, just to summarize first, second, third. Okay, before doing the question. So first levers are what? Under one second, I'll write it here. Type, ma, vr, and use. Okay, type is what? L, F, E. Load, fulcrum, effort. ma can be greater than 1, equal to 1, less than 1. Same for the vr. Use is then what? Force multiplier. Force multiplier. Now here what happens is that load is inside, fulcrum, load, E. Oh, let me tell you that Harry Potter way. Elf. Remember this. Elf. So it will always be greater than 1. We are also greater than 1. Use is then, oh no, this 1 can be force multiplied, also speed multiplier. Okay. And 2 is only speed force multiplier. And 3 is what I told you, effort is in between. So left, you just know left, remove the t. Less than 1, less than 1 ma. So this is a speed multiplier. Just remember this. Okay, now let's try to do this problem. We can see, draw how to solve such kind of question when it tells what is the class of the lever, meaning first, second, or third kind. Okay, you always draw one line, you draw 3 spots here. Start from the left. What is left? F. In the middle, L. At the side, E. So if you read it backwards, you can see this is elf. So what kind of lever is it? This is the second kind. Now if it has said FA is 60, FA is 40, AB is 60. So this is 40, this is 60. You have to tell the mechanical advantage. Now see, we know what mechanical advantage in the by the law of levers. Always write this, by law of levers. Lol. Good thing it came. Never say laugh out loud. It's law of levers. Okay. Ma is nothing but the effort arm by the load arm. In this question, the effort arm will be the whole distance here. The load arm will be only this much. Once again, only this much. So the answer will be nothing but 60 plus 40 by 40. What will it be? 100 by 40. That is nothing but 2.5. Okay, and it came greater than 1. So good. You know if it is correct. Okay, so I think we'll end it here. So see you next time in the next video.